So good afternoon and welcome to this GIRI and Passive Fire Knowledge Group forum. And we're looking at the issue of dealing with the interface between design and construction with particular regard to the fire safety sector. I'm going to give a short introduction about GIRI for those of you who are not familiar with us, and then hand over to Will and the team. Will is the chair of the Passive Fire Knowledge Group, and he'll be leading on the substance of the webinar. On the housekeeping front, can I ask you to mute your microphones if not speaking? Remember to turn them back on if you're invited to ask a question. And if you don't mind leaving your video on, that's fine, because that way we feel the meeting has a bit more vitality. If you'd like to use the chat box for questions and comments as we go through, we can pick these up and address them towards the end of the session in the Q&A. And any tech problems, well, I think the advice is, as usual, turn off and try again, and i.e. leave the meeting and rejoin using the same link. Back in 2015, an ICE best practice group asked themselves the question, how much is error costing the industry? And the conclusion was they didn't know. GIRI was founded and obtained funding from industry to carry out research, and this research culminated in the issue of our strategy for change. And these are a summary of the key findings. We employed grounded theory analysis and Delphi method in our research, and we found the overall wasted spend on error amounts to around 21% of turnover. There's a direct cost of error, measurement through NCRs and tablet records and the like, and that comes out at 5%. The indirect cost, this is the impact on other parties, particularly in terms of delay and disruption, amounted to 7%. Unrecorded process waste is where errors occur and are corrected without being recorded, and that's at 6%. And latent defects are those identified after handover at a cost of 3%. Now, this is a range depending on project size and complexity of, let's say, 10 to 25%, but it's still an order of magnitude higher than average construction company profit margins. And it's worth noting that studies in the USA and Australia came up with similar results. So it's pretty much a no-brainer, something needed to be done. The research concluded that these were the top 10 root causes of error, and GIRI's activities following the result of the research have been targeted on these highest ranking causes. Planning tops the list, and this is a planning both in a macro sense of overall project planning and in the micro sense of thinking about daily tasks. Design features in 6 of the items on the list in one form or another, and is clearly an area for attention, and that interface management of design is one of the issues we're addressing today. Culture is important, as well as coping with financial and time pressures, and supervisory skills are also a major factor. So GIRI was established following that research as a not-for-profit membership-based organisation with the strategic aim of improving industry productivity through the elimination of error. And we became a limited company in 2017. The research demonstrated that link between error, elimination and productivity. And this obviously helped to convince businesses in the industry as to the benefits of investing in a zero error program. But the world's changing, and boardrooms are now recognizing the broader range of imperatives they need to satisfy, including safety, sustainability and quality. An error-free strategy provides a platform for achieving all these objectives, and our strategic aim now reflects this. We've got a wide variety of members, small and large, right across the industry, over 120 companies now. And a key part of the organisation is to attract new members, because this gives us ensures a proper balance when we're assessing and addressing root causes. Quick look at how GIRI is going about achieving its objectives. We have our thought leadership through training, our GIRI framework for the systematic avoidance of error, our forums and webinars such as the one today, We do quite a lot of research, and the results of that research can be found on our website. We're very active in communications, particularly on LinkedIn, but we do have a library of GIRI videos available on YouTube. And there's our networking through regular members meetings held quarterly, usually in the ICE. And so the benefits, the productivity I've talked about. On the safety front, 37% of accidents can occur during rework. So it's worth noting that as a real safety benefit if you're avoiding error. On the sustainability front, clearly, if you're not wasting materials, then your carbon footprint is improved. And I think the quality benefits of getting things right is manifest. So if we're doing all that, we're going to be delivering more predictably and have a better reputation, both for our companies and for the industry overall. GIRI has a number of working groups looking at various aspects: insurance, technology, metrics, and competency and compliance. And we collaborate on a number of fronts. So we've got the PKFG and PFKG and the CROSS I mentioned there, and the Building a Safer Future. So I'm now going to hand over to Will, who's going to lead on the rest of our webinar. Thank you very much.
Cliff, thank you. Thank you very much indeed. I will now share my screen. Hopefully that will be straightforward. If somebody could let me know when the screen is on, that'd be good.
Yes, you're there.
Excellent, thank you. Good afternoon, everybody. First of all, Cliff and GIRI, thank you very much indeed for hosting our session today. It is much appreciated. So we are the Passive Fire Knowledge Group, PFKG, and the title of this presentation today is Bridging the Gap Between Designers and Contractors. You can see on the screen there that we've got a Slido QR code. If you've got a smartphone to hand, please feel free to take a photo of that, and that should open up Slido. We're only going to use it a little bit today. When we did this session at London Build in November last year, we used Slido a lot more. So we're still learning with that, but it's quite a good way of getting interactivity in the session today. So just by way of introduction to us as presenters to you today, I'll start off with myself. So my name is Will Pitt. I'm technical leader for specialist functions at Lang O'Rourke, which includes the central fire team. I'm also chair of the Passive Fire Knowledge Group, chartered engineer with over 30 years of experience in engineering. Ben, would you mind introducing yourself?
Sure. My name is Ben Oram. I'm head of technical at Buckley Gray Yeoman Architects, and I'm founder and chair of the Architectural Technical Lead Group, which is a group of architects and designers who focus on technical issues.
Paul?
Hi, I'm Paul McSoley. As it says on there, I'm the vice chair for Sibsey Fire. Like I've worked in construction for over 30 years. I currently work for myself, but me and Will, we got together, I think it was about 3 years ago, wasn't it, Will? We first sat down, went through the PFKG. I look after the process group, so nice to meet you all.
Thank you. And Paul?
Yes, I'm Paul White. My specialities are consultancy in fire dampers and smoke control dampers, and generally in smoke control and ventilation. I chair quite a lot of SEN and BSI groups as well.
Good. Okay, I'll move on. I've just realised I think I need to get a new picture because I've gone a lot grayer than that one on there. So I will sort that out for the next one. Well, certainly in the last 2 years of doing this job, I've gone grayer anyway. So what is the Passive Fire Knowledge Group? For any of you that are not familiar with this, it's nothing to do with North Korea. We are a unique not-for-profit initiative comprising major contractors, specialist installers and relevant trade associations. And we're a collaborative forum primarily to drive culture change through the design and the construction process to improve fire safety in buildings. And our mission is to improve the delivery of well-designed, specified and installed passive fire protection. And as Paul alluded to, we do this by focusing on 3 key areas, that being process, how we go to work in the area of design, the testing landscape and challenges that we experience around testing, and there are a significant number of those. And then finally, education. And we do that through things like this webinar today, talking at events and conferences, but also crucially through our website, which we'll talk about later on, pfkg.org, where we produce regular knowledge shares and guidance that are aimed at really informing the industry on a number of the challenges that contractors and architects and everybody really that is experiencing in the sphere of passive fire. These are a snapshot of our members, our founder members. As you can see, there's a significant number of main tier 1 contractors. We are also supported by a number of specialist contractors. We're supported now by GIRI, but also key trade associations, which include the ASFP, the Association for Specialist Fire Protection, BESA, which is the Building Engineering Services Association, or the trade sector for the HVAC MEP body, and FIS, which is the trade sector for the fit out interior sector. So our agenda today, we're going to scoot through quite a lot. So we're not really delving into lots of detail, but I would encourage you to have any questions ready, because we'll take those towards the end. But we'll start off by looking at an awareness of the importance of early design for passive fire protection. We'll discuss wall compatibility checks, fire damper design and specification of MEP service penetration seals, and design responsibility challenges. As I've mentioned, each of those you could talk about for an hour, if not more. So this is really quite a high-level overview, just to introduce you to some of the work that we are doing in Passive Fire Knowledge Group. Ben.
Hi, thanks, Will. So what we're talking about here is really, or a fundamental part of what we're going to be talking about today, is the need to understand the constraints for systems that are imposed when you develop a stage 4 design, but bringing the understanding of those constraints back into the earlier stages of the process. And so the Gantt chart you see here is really illustrating, for instance, the issues around service penetration fire stopping, where in order to allow enough space for service penetration fire stopping, you need to understand the detail of all the services going through it, the constraints of the wall systems. Otherwise, you just won't allow enough space. And of course, you can't have a fully developed BISRIA BG642 MEP design at stage 2. So how do you go about de-risking that? How do you talk to your design teams about this problem? How do you de-risk it? How do you understand it? And how do you convince clients that they need to allow enough time and to understand these risks? So that's really what we're going to be discussing today. We can't cover everything, of course, but maybe some of the principles will help inform this process. I think that's probably me on this one, Will.
Okay. Paul.
Thanks, Will, and thanks, Ben. I think just leading off from that as well, I think when we started first looking at process around how we do this, it was a case of looking in relation to best practice, golden thread, and how you get to a single form of truth. So what we kind of did, we sort of looked at it and went, the problem we have is that we're not very good at actually describing the conditions in the building. And what I mean by that is it's what type of building is it, who's using it, and what products or product systems do you need to deal with those risks or hazard conditions contained within it, and how do they operate? So what we kind of did is we took that approach with fire dampers initially, which Paul's going to go into a bit more detail, and started looking at around the building type and risk. What we kind of found was what we thought was actually relatively straightforward actually wasn't. It became a bit like a forest of different steps you needed to take. And probably a good example without going into too much detail is that in some instances your fire dampers needed to be motorized and others they didn't. And determining what you needed wasn't as straightforward as just going to a manufacturer and asking for a fire damper. So what it's kind of helped do by following this process is actually build it out in a way. And I think, as Will mentioned, it's on the actual PFKG website, the fire damp one is on there, and it's explained, is how you go for that set of logical steps to understand the appropriate product for your circumstances, not just relying on a manufacturer, which you can probably with some products, they can tell you where to use it, but with these particular ones, you need to understand your risk condition before you choose one. Back to you, Will.
Okay. Right. I'm just going to go back a slide there because I'm just going to show that QR code again. So this is where I'd like to get a bit of audience interaction. For those of you that missed the start, there's a QR code that's on the screen top left there. So if you've got your smartphone to hand, all you need to do is take a photograph of that QR code and it will automatically take you straight to the Slido page. What we're keen to do here is just to get a bit of feedback from the audience on some of the challenges. So which of the following passive fire protection challenges have you experienced on your projects? The options are insufficient space to accommodate a tested PFP detail. The PFP detail wasn't checked for compatibility with the supporting construction. Or finally, the PFP detail wasn't checked as being correct for the application. I believe you can choose more than one, but what will happen is it will kind of iteratively change and put the one that's getting the most votes at the top.
But it's certainly working, Will.
We've got over 200 people on the call, so it is looking like it's quite a close call, actually. It's quite interesting, that. So insufficient space to accommodate a tested detail seems to be just edging it in terms of feedback from the virtual room, which probably doesn't come as any surprise to most people, because that does seem to be a perennial challenge, and we will talk more about it as we go through our presentation today. But no, useful thing, good to get some feedback. So thank you everybody for that. Okay, Paul, back to you.
And I think the result there is quite interesting, really, because I think when you look at it, Will, it's a case of, you know, with the fire damper one especially, was that we couldn't get the right product, and you see it amalgamate itself in the wall. But I think this slide's quite powerful, and I think I will improve this slide, because it's a bit out, it's like my picture as well on the start. It's a bit out of date, but what we're trying to portray here is that the caution is that we're looking at all the different products, but not in the product isolation. So we're assuming that they've all got the same rules and how you put them in walls, and actually they haven't. So what we're trying to describe to you here is that flues, chimneys, don't do the same performance as a fire damper. They carry flue gases. Pipes carry water, what we part H, you know, your toilet and your drainage. It could be rainwater. It could be chilled water, which is part L. Fire doors aren't necessarily just a fire door. It can be powered access. I think Hannah Mance was on the call, actually, but it could be other different things as well. And when you look at this, you know, you can't just assume that you get a fire door and you're done. You might have security as well. You might need vision panels. So all in all, when you look at all the different components, are we actually sure we've got the right component initially for the function, and then does it work with the wall? Because some of these, unfortunately, will require rigid walls, not symmetrical partitions. And you might find, and we've seen this before, where someone's designed the job based upon lightweight partitions, and you suddenly realise you need rigid walls. So having an overview of what all the products do and where they need to go early on is critical in the process of making sure your design's correct.
I think this is you, Paul White.
It is, yes, yeah. So just bearing in mind what Paul's just been through, we're going to now zoom in on the dampers. But of course, you've still got to be aware that if you've got a load of penetration seals or penetrations with pipes and cables, you can't necessarily put them right next to a duct or a damper and all those things. And going through the selection process is where we start. So we really need to start right back at what type of building we're looking at, what purpose group it has. Is it going to have people sleeping in it? Is it just an office block? And then you find that different rules will apply. There's 2 ADBs, as probably everybody's aware. And then we're moving on into that, and we have to look at the compartment resistance time. And then we go into it a bit deeper in terms of space risk. Is it just fire? Is there a chance of smoke? Is there a refuge there? Will firefighting be taking place? Is it simultaneous evacuation or perhaps phased evacuation? And taking all that information into account, that would then give us the classification for a fire damper. And again, It might be a curtain fire damper, or if there's sleeping risk or risk of smoke migration, it would be an ES classified product. And those have additional issues with regard to RL, because if you've got a fully open curtain fire damper, you have little or no resistance. But if you've got a motorized multi-blade damper, then you'll have different resistance, and that could affect your fan sizing. So having then picked the classification of the damper that you require, you then have to interrogate which wall it is, and then you suddenly realize that very early in the design process, you need to know what the wall is, because all the different manufacturers have different installation details, and they may require bigger or smaller holes depending on what type of wall it is. And therefore, you may not be able to put the damper as close to the ceiling as it's shown on the drawing. And we've got then a typical detail on the right-hand side there, which shows a flange damper being pushed into a flexible construction. And you can see that there's a lot of details there that you need to bear in mind, and you've got to allow space for. And you've also got to allow access on both sides of the product to allow for cleaning. Could I have the next slide, please, Will? So we've got the classification, we've got the wall type, and then that gives us the potential for what type of installation method. And as I mentioned, you've got to be aware that different manufacturers have different installations and hole size details for different types of wall. We just pick up the fact again that depending on the blades in there, you may have issues with regard to part L and resistance in your ductwork calculations. Then we may be looking at, is it in a wall, is it vertical, is it in the floor, horizontal, and then you have to then see if it's motorized or not motorized, and then we can see that it has to go in the wall, but it's not allowed to be right up against the ceiling. It needs to be a certain distance from the walls. So all this needs to be taken into account much, much earlier on. Then we can then perhaps, then we've got the wall types, and then we've then got to also be aware of the other services going through it. And then we're looking at what the actual very close installation method is. And then that's all tied back to the classification with the manufacturer for a particular wall type and the installation method.
Okay, Paul, thank you. So that was a quick look at dampers and damper selection and all the issues associated with that. We're now going to discuss very briefly the subject of penetration seals, design and specification of that. Now, there is a more detailed presentation of this, as there is on the dampers, I should say, actually, on the PFKG website. So please reference that as you require. But specifically in relation to penetration seals, I thought it was useful just to start off with a bit of a kind of a warning slide, if you like, really. So not planning for this, not planning for MEP service penetrations at design stage will, as we've just found out interestingly on our Slido, it will lead to insufficient space to incorporate tested details. It is then likely to require the need to seek an opinion of the likely performance of a non-standard detail. An opinion, that's an interesting word, isn't it? And we talk about engineering judgments and assessments and so on, and the fact that they are increasingly not liked. It will lead to a significant compliance issues, and as anybody that has been involved in this on the call will know, it will lead to a world of pain. So we're trying to do things differently now. Again, this is talking specifically around service penetration seals, which generically used to be referred to as fire stopping, but for the context of this, we're talking about pipe work, electrical services, dampers, that kind of thing. So this is a kind of a recommended process, if you like, that if you follow this, it will lead to much better outcomes, and it is all about being able to apply manufacturer tested details. So we start off with spatially planning the services in accordance with a rule set. Now, these rules might be generic. They may be developed based on specific manufacturers, and I know different people have got different ways of going to work. And there is some work going on with the Pacify Knowledge Group on this that we'll talk about in a bit. So the first thing is ensure that the services are spatially planned in accordance with some rule sets, and that will enable those details to be tested and applied at a later stage. The next part of the puzzle is the architecture needs to be updated to incorporate these spatial requirements. So, for example, that might be ceiling voids, it might be width of corridors, it might be basement where there are smoke control systems and we need specific distances above doors. All this kind of stuff needs to be thought about at REBA stage 3. And if it's not thought about, in all likelihood, you won't have sufficient space. So at that stage, it's all about just kind of land grabbing, if you like, I think is the term that we're using. Then we move into the technical design, and it's really about ensuring that the MEP model and the architectural model are talking to each other, that they are coordinated. What does the architect do? Broadly, it is about owning the position of the aperture in the substrate. So the services engineer or the services designer will be responsible for the services and the size of the aperture, everything within that. And then the position of that builder's work hole within the substrate needs to be owned by the architectural community. And I know there are some discussions going on around that in more detail, but I'm trying to keep this at a relatively high level. You can see on the screen the image there, which was courtesy of British Gypsum, but that is showing a builder's work hole with the services in it, and it's then being coordinated with the dry lining. But there's also other things that need to be thought about: deflection heads, door positions, stability, etc. There will be more. I'm just listing a few off the top of my head. So the final part of the jigsaw is that the application or the specification of a third-party tested detail. Within the more detailed presentation on the PFKG website, we're calling this a specifier role. There are a small number of companies that are doing this now. There aren't many, admittedly, and it is a challenge. But what this role is doing is essentially applying a manufacturer-tested detail from a library that they may have to each individual builder's work hole, providing the rules that we've kind of set out earlier on are followed. So the services are laid out properly, they've been coordinated, the architecture, the whole position has been coordinated. The actual application of a tested detail should be pretty straightforward because the rules have been followed. If we haven't done all this, as I've mentioned in the earlier slide, you're going to be in a position where you're going to be looking at non-standard details and getting opinions on the likely performance of something which is untested. And it's really becoming a significant challenge, this. So this is a sort of an overview of the process that the Pacify Knowledge Group have detailed more broadly on our website in order to be able to get to a position of designing services penetration seals from the outset. And as you can see, this is a multidisciplinary thing. This isn't the domain of the MEP engineer. It's not the domain of the architect. It's kind of everybody's responsibility to get it right. And I think that is possibly one of the reasons why it is proving to be such a challenge. Ben, are you happy to take this next slide?
Sure. Yeah. Thanks, Will. I think what this is sort of coming to is the relationship between the smallest detail on the project in some way, or one of the smallest details on the project, and its wider impact on the whole concept. So one of the principles that we're talking about today is how to bring this knowledge back in the design process earlier, or left on the page, let's say. And so we need to be really careful that we have enough space, for instance, at the concept stage, to allow a compliant detail to be picked and specified at REBA stage 4 and during the construction phase. And what we're finding, I think, is that this is obviously a very, very tricky thing to do. We're being, I think, as an industry, being pushed to design faster and faster. We're being pushed to to overlap and to merge stages and skip stages. And all of this is leading to these issues and these problems around rework that we're finding on the site. So just to talk through this slide here, of course, our stage 2 is a concept design, but of course at stage 2, often you're actually locking in key parameters in the building, like the building height, for instance. You're often submitting planning applications. You're actually setting quite fundamental rules for the building. For instance, you might set the height of a residential tower, and you can only do that if you allow enough space at that stage for realistic compliant details. So this is one of the key challenges that we all have. How do you do this? How do you talk to your clients and your design teams? It may be, for instance, that you need to start bringing packages of information forwards or appointing specialists. So, for instance, at stage 3, one of the things that is often, I think it's being talked about in the industry is, do you bring in bring in specialists to try and de-risk the design at that stage, who can coordinate and can advise on these details and can set a set of parameters for the design team to work to. Also, we're finding that often you may be actually doing quite fundamental pieces of work at stage 3 before you've actually started stage 4. So I think it's common now to see demolition work start on site during stage 3. Often parts of enabling works and permanent works are actually installed during stage 3 while you're still designing stage 4. So I think that it's important that we are very, very conscious that if you're doing this, it imposes a series of risks upon the project, and that you convey those risks accurately to the rest of the design team and to your client. Of course, this has impacts on cost, design flexibility, and design fixity. But I think we have to be aware as a design team that you are balancing speed of program against cost certainty. I think, Will, if we can just switch to the next slide. So the process that we've been discussing as part of the PFKG is that we very, very carefully at stage 3 define the performance classifications that we require. We identify that there are suitable products available on the market to achieve those performance requirements. And we start to define key builders works in connection to suit these third-party details, at least as a concept, so that you know that what you are designing can fit and can also achieve the performance requirements without requiring you to, say, swap wall types or go back and re-specify entire ventilation systems, as Paul was talking about earlier. Then once you've done those processes at stage 3 to give yourself comfort that this can work, you develop the internal substrates build-ups to suit a third-party manufacturer tested detail, and you incorporate the internal coordination of penetration seals at BSRIA 4.1. That's important to say here that the REBA plan of work defines REBA stage 4 as all technical design. Now, a lot of the projects now are procured using a designer build contract, where stage 4 actually spans between the pre-contract and contract phases. So often the full MEP design required to de-risk these surface penetration stoppings is not available to the design team until the contractor is appointed and the MEP subcontractor fully develops the BSRIA 4.2 design. So we need to be really careful that we are making suitable allowances so that compliant details can be selected during the contract phases. Thanks, Will.
Okay, cheers, Ben. Paul McSorley, do you want to take these last two, or do you want me to do that?
No, and I think we'll do it between us, but it's not a problem. I think the biggest thing here is, and Ben, that was really, really good. And I think there's some really good questions in the chat, Will, coming in as well. There's one that I don't want to answer, but we'll get to that one later. You'll probably spot that one. But so look, basically, when it comes down to your general penetration seals, the option is select 2 to 3 fast open manufacturers at stage 3 and spatially coordinate the worst case. It's a really good approach to doing it. I think the thing to consider still is just making sure from an MEP perspective, we've got the pipework nailed down, or whatever's going through it, we know what the products are. Because I think Ian Ouch has done some really good comments on here as well, so it's good to have his support today. But I think when you look at it, if that changes, then you can get yourself back to the start point, which is what Ben's alluding to. you can't have this point where you haven't ratified what the products are for the pipe work. It's not just the fire stopping product that's the issue. The pros are allows you to spatially coordinate to be completed whilst maintaining a degree of commercial competition. But again, providing you're not changing the pipe, the fire stopping, you get a commercial advantage by having that process. It works quite well. The cons are slightly less efficient in spatial use, only works for Part 3 products. And I think this is, as Paul was saying earlier, the big things, I think the way to probably imagine it is that fire dampers have an operational function because they shut, but also they prevent smoke spread and non-smoke spread. They might need to be insulated as well, depending on where you're using them. Whereas the Part 3 products are quite static. They go around pipes. They may intra-mess. And I'm sure there'll be people in the comments that will say there might be other ones that do slightly different functions, but essentially it's not the same thing, if that makes sense. So doing it earlier, the pros, I think my view is it outweighs the cons, because at least then you're in a better situation to understand your access requirements. I think Ian said that as well. Make sure you've got access both sides. Bill, do you want to add anything? Or are you happy?
No, I think that's it. And then ducts, dampers, encapsulations. You want to do that one, Paul?
Mr. White or Mr. Me?
Well, I think that this is essentially the same principle as the previous slide. It's just that it's focusing on ducts, dampers, and really there are a couple of routes that you can go to work here. The first one is where you select and define products at stage 3. You know your colours to the mast much earlier on. Obviously, the advantage of that is that it allows accurate details to be coordinated and it reduces your design technical risk. But as a disadvantage to that, it means that because you're uniquely specifying much earlier on, there's an argument that you're decreasing your commercial competitiveness and all that kind of stuff. And I think that is probably a high level is a real conundrum that we're struggling with as an industry at the moment around all this in particular.
Well, I think, Will, just to add to that, if you take the point earlier about the rework that Cliff pointed out, do you want to spend your money there or do you want to get it right first time? You know, so mind the pun there, by the way, but do you want to get it right first time? That's the conundrum, isn't it, Will?
Absolutely. And really the alternative, which is shown in the darker box below, is that we look at being a bit more generic. But clearly the disadvantage of that when you're talking about ducts and dampers is that it becomes difficult to achieve it and you're going to have more coordination issues. So yeah, Paul, you're totally right. It's I think we're all on the same page. It's about designing earlier based on specific products and incorporating it. And I'm fully aware that that is a significant challenge for the industry, but I think that probably is the direction of travel.
Sorry, Will, just briefly, I think the other thing to bring in is obviously depending on what the products are. If you're allowing space for one and you end up with the using a one that has different dimensions, that you may not have a required installation method to go with that. So things get bigger and smaller. And then I think the other point to come back to Ben's slides is we're talking about rebus stages, but you've also got to be aware if you on an HRB, you're going to be checked about against your design at Gateway 2 to see that it matches at Gateway 3, and things like dampers and smoke control with smoke control dampers in it. That could give you a big issue if somebody's decided to change their mind.
Absolutely, really good point. Really good point. Conscious of time, I just want to finish off by there's a link. It's not a link. That's our website, which I won't demo now. But if any of you that haven't looked at it, please feel free to do so because it's got the knowledge shares that we talked about and also the best practice information that we've got in more detail on there as well. We've only got 20 minutes left, so I'll stop sharing at that point. I think it's probably a good time to go to the Q&A.
Will, I'm just going to enable microphones for all the attendees so that people can unmute themselves to ask their question, if that's probably the easiest way to do it. So, I mean, if we start at the top of the Q&A, I think Gregory Malik, you had a couple of questions that you posed in the chat. So maybe if you're happy to unmute yourself, then you can fire away your top question.
Hello everyone. Will, Paul, thank you for another good session. I worked before on the Diohas group. We are facing the same problems. Nothing has changed since 2023. And the first one is the smoke shafts are biting us quite a lot. We don't know where to go. RC, blockwork, fire-rated ducts, even the building services engineers involved provide a very vague advice. And then when we get to the bottom of it, we don't know who should be fully responsible for the full design.
And I'm guessing, well, I'm going to be taking this one, yeah?
I think you and Paul White are firmly in the hot seat for that one.
I did say there was one question in the chat. I was a bit like, here we go. And this is that question. There's nothing wrong with the question, Gregory. It's been a bit of a problematic debate for a while, this. And there's no simple answer to say, and I think before I go on, actually, I think, Paul, you would say this as well. It's not fire-rated ducts, is it, Paul? It's smoke control or smoke extract ducts. So
it's smoke control duct, so which is fire resisting duct +1, if you like. So yeah.
It just points out the language barrier that we will be one of the biggest problems we've got is language barrier as well, because these things are quite complicated. So it's no criticism or anything like that. I think the hard bit is, I think when you look at this, going back to Ben's slide, the best way I can probably put this is that a decision needs to be made at stage 3, or maybe even sooner than that, on what appropriate type of system you need for your building. And I think what was happening in the past, I think you'll all relate to this, is that we've gone from probably using ducts and brickwork shafts years ago to lighter weight materials like drywall. We've ended up shrinking these things down and down and down because there's been another way of challenging what was right, wrong or indifferent. But we've got to consider there is other factors. There's pressure, there may be a lot of water sloshing around. There's other things that can affect those type of shafts that are constructed, and the decision on what material you want to use and actually what system. Do you want to extract it out? Do you want to pressurize it? Do you want it to naturally escape? Those kind of decisions have to be made a lot earlier on. I think if that's done, you'll get to what's appropriate a lot sooner. But it doesn't help if you're in construction at the moment, and there's not an easy answer to give on that one, I don't think. Paul?
Yeah, I think that's the point. And again, a lot of the systems that have gone in have probably been compromising, because people will put shafts in the core because that's where they're building it. They won't close them off. They'll put a fourth side on later on because it's easy. And unfortunately, these things don't lend it to where it is. I mean, if you've got an extended corridor, you should be extracting from the end of the corridor, not right next to the door to the stairwell. But people have overcome that. I mean, and there's huge issues with that, with firefighters opening doors into apartments where there's a fire, when the fire's being drawn out back towards them and down their escape route. And it's because these things aren't being considered early on. But also, you can have but you can potentially have shafts for different systems. So if you're using a pressurization system, then potentially the pressures that you find in the shaft will be very low, but obviously in extract they could be very high. So it's all about horses for courses, and it really does come down to, going forward, that we must design the buildings properly to suit all these services. So that includes your smoke control, it includes your sprinklers, it includes your ventilation layouts, and it includes all your pipes and cables. Towards the start.
I think there's just one little thing, because I know we need to move on. I think Lee Ramage is on this as well. So Lee, your comments are really useful in the chat as well. And I think if you take the smoke control ducts file and to get it right, and you look at the cost of that system, it's going to be on the PQS's eye straight away because it's expensive. And that's one of the things that's been driving this as well, because I think value engineering has been mentioned in these chats as well.
Thank you. Just, I think the next sort of comment or question in the chat was from Ian Outram. So Ian, if you're happy to unmute yourself, that would be great. And just
happy to unmute myself. More a comment. The words I was hearing were all for detailed distances was picked specified compliant to manufacturer's minimums. Fantastic, but then you make them unbuildable.
I did like
So
your comment
it's
here.
no good sticking a set of numbers in a computer because it will put everything in a position where you can't get a hand to make a compliant fire seal. So it needs a lot more thought than just minimum distances.
Yeah. And I think, Ian, you'd agree with this, not to lane this point, but I think one of the mistakes we all make is we try to make it simpler than it is. It is actually quite complicated to get this right, you know?
It's incredibly complicated to get it right. And I mean, it's included if you want. I haven't seen a manufacturer that gives you enough information on service distances to reach your compliant goal, unless you state 100 mil.
Well, don't worry, we'll change the pipes before you put it in anyway and not tell you, so don't worry, yeah?
Always, you'll find a different manufacturer or a different material just to annoy, yeah.
Just to respond to Ian's point, do you think that the industry manufacturers should be doing more to help designers in that sphere? You know, there's a lot of testing going on with minimum distances and separation and so on and so forth. Is there more that could be done to help designers understand about the installation space requirements and so on?
I believe there should be a lot more done to help designers with installation space. I've been on many sites where you see a solid row of cable trays with all the pipes above and no room to get your arm in each side of the wall. So they'll never be done properly without taking all services down again.
It sounds like a data
and
center.
that doesn't get met with a smile on site when you say take all the services down.
So it sounds like a data center corridor, that one, Ian.
Well, it also happens in underground stations, but we won't go there. The key point is I think that a lot of this perhaps is that some designers maybe need a bit of vocational experience and before starting work on a project, maybe go and have a look at some of the installations on the other projects and see where the issues are that are maybe caused by the designs that can be done on paper without a practical application or experience.
I think as well, the knowledge shares are raising that as well, aren't they? So that's a good thing because they pick up on a lot of those dilemmas we're coming across, which is helpful.
No, but I think Ian raises a really, really important point, and it's definitely something that we need to be thinking about.
Yeah.
Great, thank you. Hassan, you've got your hand up, and you posted a couple of comments in the chat as well. So do you want to unmute and fire away?
Thank you. Great presentation, guys. Just on the point that Ian just made about the minimum distances and what have you, I think very often we tend to give very little thought to CDM as well and the maintenance aspect of these sort of things. So, you know, while it's all well and good relying on minimum distances, you know, it's still got to get installed, it's still got to get maintained. And quite often what we find is a lot of these things tend to fall away through the coordination process, where, you know, the first time let's say the first time it gets designed right, but then, you know, your primary steel, your grid lines, your ceiling heights, things like that often change through that design process, and then these sort of things kind of fall away in that process because there's so many different facets to fire, you know, to passive fire and active fire. It's unfortunate, but these sort of things do happen. But I suppose it's we've just got to get better at sort of dealing with these things. There was something else that I wanted to mention, but it's kind of gone by me now, sadly. It was a really good one as well. Oh,
we'll do that, mate.
It's back. Paul, you got to love this, as is Ben. Design responsibility.
Yeah.
Now, we get this all the time. Fire, generally, passive fire protection has so many different facets, and there's all these different consultants and contractors that are involved in the process. And I think quite often, everyone knows what they need to do. Unfortunately, not many people want to take responsibility for what they need to do. And I just wonder whether, you know, what's the consensus?
I mean, Paul, you can jump in if you want first, because you know me, I'll talk for Britain. Sorry.
I would actually refer you directly back to Part 2A of the latest Acts, and it is incredibly clear who's responsible for what. And unfortunately, it doesn't necessarily match contractual arrangements. So you can set contractual arrangements, but that doesn't mean that people can break the law to actually apply them. So, and this is a difficult bit. I mean, I refer people back to 7346 Part 8, which is the design and implementation standard for smoke control systems. And the very first thing it says is put a matrix together to make sure everybody knows who's responsible for what. And this should be the first part of the whole design process, as far as I can see. It doesn't matter which segment it is. But at the top of this, we have a client who has to provide a principal designer, and that principal designer is responsible for all of it, whether they want to be or not. And they need to make sure that they're employing other people to do the bits of design that they don't know how to do.
Can I jump in there, Paul, and just so I mean, one of the positive things coming out of the amended building regulations is that there is this onus on the client to provide sufficient time and resources, including expertise required to de-risk these things. There is this new role of the building regulations principal designer whose what's the word, responsibility is to take all reasonable steps to plan, manage, and monitor and coordinate for compliance. Those two things together, I think, are great positive changes in the industry. So they will push the onus on the push process of getting these things right at the right time in projects. But I think there is this important point that the BRPD is planning, managing, monitoring. It is up to the designers to design in a compliant way. And so it's for the designers to flag up if they don't have enough information, if they don't have the expertise, if they don't have the competence to get these things right at each stage. And I think you're completely right with that British standard that there is this gap, let's say at stage 2, in understanding how big do you make your risers? Where do you put your risers to do this correctly? And so there is an onus, let's say, on the architect to say, well, I don't have that information, so I can't plan those properly out at stage 2. There's a onus on the BRPD to flag this up and say, oh, there's a big gap in your compliance here, and there's a requirement on the client to say, oh, there's a big gap here. I need to appoint a suitable specialist at stage 2 to get this right. So I think there's what's the word? Is it light at the end of the tunnel? There's a positive direction, but I think we've got a long way to go still.
Yeah. And I think, Ben, just I don't want to bog this down, but to add to it, I think for you, Hussein, as well, is that if you take the penetration seals for pipework, there's a designer of the pipework, there's a designer of the wall, and there's a person that puts the little bin at the end. So if the first 2 bits haven't gone through a natural step, don't expect the last bit to be maybe correct. I think that's the point that, we kind of allude to as well. So I think from Ben's point, not speaking for you, Ben, is that the principal designer may not know all of that, but you will need to have an understanding that once something's locked in, you can change it without the ripple going through. And I think that's what's gone on in the past. I think Lee Ramage was trying to put his hand up just now. If he's still around as well, I think we'll bring him in if that's okay, because I think he had a few good points.
I was just going to say we'll come to Lee, but I'll just quickly butt in to say that we've got quite a lot of questions and we're probably not going to get to them all. So we will pick up the chat afterwards and get back to people by email if that's helpful. Over to you, Lee.
Hi, sorry, I was trying to reply off the back. I think Hassan's comment and Ben responded as well. It was more to do with the ownership of the design. So things are a bit, I'm sure I'm not the only person that works in Scotland as well as England on the call, but it's been an ongoing problem. Principal designers being selected on the absolute bare minimum of a scope, but that's been compounded probably since the BSA was introduced, with architects either through insurance pressures or through a distinct lack of technical teams as opposed to Part 2 graduates being competent in detailing that level of information. And that's something I think they recognise, but I don't think that's something the industry can fix. I think lobbying the insurance industry to help us fix that would be better. But that's something that's probably more acute in larger public sector projects in Scotland than it is in England, because we don't have some of the or any of the BSA stuff to fall back on. We've got a diluted version of that in our regs, which isn't really fit for purpose. But it's not. I don't think it's a lack of knowledge about people's responsibilities or the roles' responsibilities. It's a lack of ability to deliver on them, whether it be insurance-led or it be, as you said yourself, competence or knowledge-based. And that's something that the whole industry has to take very seriously, because it's going to get to a point where the architects are looking to hand over to a contractor team at stage 3, much in the same way some of the MEP consultants do, which isn't going to do anybody any favours, I don't think, in the industry.
Okay. Thank you. That's really helpful. Michael Croxford had a question in the chat. Michael, if you wanted to unmute yourself. You're still here.
He's there, but he can't hear him.
Come on, Mike, get the mute button off.
He's on silent.
Is he?
Okay.
It's the
Should we
tech.
come to well, while Michael's sorting that out, should we come to Olga Tarasova?
Yeah, hi. Yeah, we were just talking about early specs, and it's kind of like, I think you mentioned even expecting something at late stage 2, early stage 3, but then what happens if the contractor comes in on board and just value engineers it all? Or then, you know, sometimes I had such things happening on my projects quite often, actually, and what I've been focusing on is lots of reclad jobs following Grenfell. And I think that's a major problem in the industry, because you know, it looks like architects, almost, just in case I'm an architect, work for an architectural practice, and I think that you know, generally in the industry, people tend to believe a contractor rather than listen to an architect. So we need to defend our position a lot with the specs.
Don't we think that the building safety regulations are going to mean that to get gateway approval, particularly gateway 2, that we are going to have to get expertise and competence in the design to pass that gateway, and thereafter, if there's an attempt to value engineer, that any changes to that design have got to be approved back up the chain, and it's going to become less and less cost effective for people to make those changes, because they're going to be so difficult to implement. And when you tie that in with the need for the golden thread, and the other thing to bear in mind is that we talked there briefly about the individual who's the principal designer, who's got to sign off that design to say that the whole of the design is compliant with the building regulations, and they will be accountable for it. But at the end of the project, somebody in the contracting team is going to have a similar responsibility to sign a document to say the building has been built in accordance with the approved design. Now, we haven't got to that bit yet, but we're already having 50% or more of the submissions at Gateway 2 failing because they're not encapsulating the whole of the compliance with the building regulations. And life is going to change, definitely.
Cliff, just to also point out that the client also has to sign a similar document alongside the contractor, that they've accepted that the contractor has built it incompliantly. So we wait to see.
But that's only if the building goes into the BSR. What if if it's not a high risk?
I think you're right that at the moment it's HRB, but I think it's going to spread, because we've got the building regulations apply to everything, not just HRB.
Yes, it's just a gateway process for the HRBs. I think the other rules apply to everything.
Yeah, they do.
Just
Michael,
one thing
sorry, go on, Ben.
Just very quickly, I was going to say to Olga's question about spec changes. I think one of the things that we have to be really careful about as an industry is if we are designing these things, let's say to these fire seals to a complete stage 4 product selection, etc., before contractor involvement, and the contractor wants to VE down, then the contractor has to pay the design fees to completely redesign all and reselect all of those
Right.
systems, and to do all the compatibility checks that you've done already. And that needs to be factored into the value engineering process, that cost is enormous and will probably offset any cost reduction through the V process.
I used to say if the cumulative effect isn't saving £1 million, then I'm not doing VE.
Michael, should we just try and squeeze your question in? We're just going to run over time slightly, but
So it's always time for Michael Croxford. Always time for you,
sure.
Michael.
Thank you, Paul. Love you. It was round. Ben's just answered it effectively. That it is that case of when a main contractor comes on, they start to VE or want to VE in line with their supply chain. Should the main contractor be getting brought on board earlier to influence that, to stop that design work? Because Paul's scratching his head, but from his Mace days, there'll have been certain people at their business would have wanted him to use. So, questions.
I think, Michael, it's a real big point. This, and I think one of the things I'm going to go back to it is that no disrespect to cavity barriers, because they're quite static and they sit in a facade, but some of this other kit, the classification numbers and performance are enormous. They could do multiple different things, and it's getting to that bit which is proven quite difficult. And I think when you look at, I think it might have been Yuli that put the comment in the chat about supply chain. I can't remember. There was someone, and I'm not a verified user, but the hard thing is sometimes your supply chain just might not have the products that are required to meet the condition. And that's the hard bit as well, isn't it? Do you know what I mean? It's how you get that teased out at the earliest possible stage. Obviously, goes without saying, Michael, yours will meet everything as far as I'm concerned. But
okay,
I think we're up for time, but we will pick up any further questions and get back to people if there are queries we haven't got to. And also, just to make a quick plug for GIRI members, our next members meeting, we will have a representative from the Building Safety Regulator presenting at the meeting. So it might be interesting for some people to see that. So, Will, I don't know if you've got any kind of closing remarks.
Well, just really interesting to see the chat there. I mean, there's obviously a significant demand for all things technical in this area, and I think as a passive fire knowledge group, we are a collaboration. We all have day jobs, but we will try and look to address some of that feedback and those comments. I'm not quite sure how. It might be through LinkedIn to stimulate further debate. But we'll pick that up because we meet monthly. So we'll pick up the feedback from this session and look to address it.
Well, we at GIRI will also help with the dissemination of knowledge and advice. I mean, Lee was at the at our competency and compliance forum on Friday, where we touched on this issue, and we'll certainly be taking that forward in a lot of the discussions. I just want to say thanks very much to our presenters. Really very interesting stuff, well worth airing, and it needs a lot of industry knowledge to move us forward. Thanks very much.
Thank you.